So good morning, good afternoon, or good evening. I think we can consider this the first instance of the Antrea community meeting for year 2022. As you probably know, we had a very short meeting on January 4th, but as there was no topic on the agenda, the meeting was cut kind of short immediately. And therefore, this is our first real meeting of the year. Today is January, Wednesday the 19th. Of course, if you are in the United States, you're still in the past, it's still Tuesday, January 18th for you. And in the agenda for today, we have a discussion of the multi-VLAN implementation for Antrea IPAM that will be led by Ran, and then open discussion. And I think that's all for my introduction, and therefore I will leave it to Ran for presenting his design.
Okay, can I start?
Please go ahead.
Okay, today I'll introduce the multiple VLAN support with flexible IPAM for you. And okay, let's start. First, I'll introduce about the flexible IPAM. Antrea previously uses the node IPAM, also with the host local plugin by default. This method will allocate a CIDR per node. So if a pod is evicted from node 1 to node 2, it is unable to keep the previous pod IP for the new created pod. Since Antrea 1.4, we provide a new IPAM mode, which named Antrea Flexible IPAM. And this method supports users to specify an IP pool for each namespace, pod, or stateful set. And it can work with node IPAM at the same time for different pods. And here is a roadmap for flexible IPAM. In Antrea 1.4, this is an initial version to support the flexible IPAM. And this version supports users to specify IP pool for namespace, and also only Linux with IP version 4 is supported. And in Antrea 1.5, we do some enhancement for the support metrics. We support users to specify IP pool and IP for pod and stateful set and deployment. With Antrea 1.5, the pod IP can be kept if it is specified, or if it is a stateful set pod. And for the next Antrea 1.6, we plan to support the multiple VLAN, which can provide more flexibility for the scale. And we also have some work items in our queue, but this is not defined at all, such as flexible IPAM for secondary interfaces and IP version 6 support, Windows support, and the end control support. Here is an IP pool example for the new multiple VLAN support. So we extend the IP ranges item with a VLAN. So users can specify the VLAN for each IP range, and the default is 0, as we currently do not have the VLAN for IP ranges. And here is OVS flow enhancement in Antrea 1.4, with flexible IPAM. With the flexible IPAM enabled, we need to bridge the uplink to the OVS bridge, which default name is brint. And we also need to configure the node IP to the bridge port, which will have the same name with the OVS bridge. And also the Antrea GW0 and existing port will not be affected. And for the new port, which named Antrea IPAM port, it is also bridged to the OVS bridge. But all the port is in default settings, which is trunk mode, and it will allow all VLANs to pass this port. And for Antrea 1.6, we need to add the multiple VLAN support. So firstly, we need to set the existing port as the access mode and with VLAN 0. But we can also keep it in trunk mode. If we keep it in trunk mode, it is friendly for the upgrade scenario, because we don't need to change the existing port mode. Both of the two methods can work. And for the new Antrea IPAM port with VLAN, we need to set the port mode as access and set the specified VLAN. Also, the layer 2 gateway need to configure the multiple VLAN, configure IPs for the multiple VLANs. It also need to provide the inter-VLAN access, such as for the VLAN 100 and the VLAN 101. The traffic will transfer from the one node and to the layer 2 gateway, and the layer 2 gateway will send it to another node. But if the traffic is an intra-node, the OVS will send the traffic directly from port 4 to port 5. Next is OVS flow tables enhancement. Because Antrea uses the OVS table 110 as the output table to output packet to OVS ports. And if we want to add the multiple VLAN support, since OVS won't process VLAN tag automatically if we specify the output port, we need to add a new table to process this work before the output table. And if the source import is access port and the output is access port, we don't need to process the VLAN tag, because the packet is untagged inside OVS. And if the import is access mode and the output is trunk mode, we need to add the VLAN tag to the packet before we send the packet to output table. And if the import is trunk and the output port is access mode, we need to pop the VLAN tag. And for the normal action, such as the broadcast, such as up request, we don't need to do any additional process for the VLAN tag. OVS will set it automatically when action is normal. And here is an OVS flow table example. So we can see the last table is output, and the previous table is hairpin SNet. We need to set the go-to table action from the output to the VLAN table. And we add some flows in VLAN tables to process it, such as if the import is uplink, and we can believe the output port is not uplink, so it's a access port, so we can just pop VLAN. And if the import is a IPAM VLAN port, and the register 1 is which stores the output port number, and the 3 means the output is uplink. So in this, if the packet matches this flow, we need to add the VLAN tag for this packet. And also we still have some open items for this change. First is feature gate name. We already have the Antrea PAM feature gate, but if we want to add another configs to switch on or off the multiple VLAN support, we need to decide a new configuration. And the second item is I mentioned above. We can use the trunk port for the VLAN 0 access port. If we keep the trunk mode, we don't need to modify the existing ports, and it can also work. And next one is flexible IPAM for the secondary interface. So I think we already, the secondary interface PRs is still in working, but we may consider to make flexible IPAM to support the secondary interface for the IP allocation. Okay, that's all I want to share. Any questions?
Hi, Lan. Thanks for sharing. And for the open questions, I think for the first one, do we really need another feature gate to enable this multiple VLAN support? Could we just when there is when users specify a VLAN for a port, then we behave differently? Why?
Yeah, it's okay. But if we use this method, I think it is better to use existing trunk port for the second open items.
Yeah, I agree. I think the configuration of normal ports, I mean the ports get IP from node IPAM should behave the same regardless of the enablement of Antrea flexible IPAM. Otherwise, the code could be complicated.
Yeah, I think we can keep this part in this graph. The VLAN 0 access port can be the trunk port with all VLANs. It is the same as before. So I think it's better for this. And if we use this method, we can just keep the feature gate the same. We don't need to add a new switch to configure this feature.
Thanks.
Hello, Ran. There is something that I did not understand about the flows. Can you go back to slide 8, the one with the flows? The second flow, the one that applies the tag, you say that it captures it says import, and that's that's the pod port which is supposed to be tagged, and then registry 10x3 means uplink. This is what you said, right?
Yeah, the register 1 will store the output port number. So you can also you can see we have the output, this flow in the output table.
Yeah.
We output to register 1.
I see. No, that's this is clear. It's just that we are matching therefore on traffic that is from the pod port to the uplink port, and we apply the VLAN tag to that traffic. Is that correct?
Yes, because this all the packet inside OVS don't have the VLAN tag.
Yep. No, I understand this. I'm trying to figure out what is the expected behavior for VLAN traffic between two pods that are supposed to be on the same VLAN, which are on the same host. Do we send it to the physical network in any case, or in that case, will we forward the traffic locally on OpenVSwitch?
Yeah, if a packet from the one from the one VLAN port to another VLAN port, both of them are access mode, we can just output the packet to the destination port, and we don't need to touch VLAN.
Okay, I understand the design. Okay.
So we can because if a packet from a VLAN port, we cannot get the VLAN tag inside OVS.
Okay.
But if a packet with VLAN tag is from a trunk port, we can get the VLAN tag. So I think it's a strange behavior, but OVS implement this as this.
I understand. I understand. Now I'm just asking this, to. Sorry if this is a stupid question. So this means that we are not able to tag the traffic if the traffic is supposed to be local in the same OpenVSwitch instance. So if you have two pods on the same VLAN on the same OpenVSwitch instance, the traffic will be forwarded, let's say, using normal forwarding rules, but it will not be it will not have a VLAN tag. Is that correct?
Antrea won't use the normal action as the forwarding. So all of our traffic except the UP or IP SMP version 6 broadcast will be output to a specific port in the output table.
I see. Okay, so summarizing, let's now think about a different scenario where you have two pods on the same OpenVSwitch instance, which belong to two different VLANs. Let's say one is VLAN 100 and the other one is VLAN 101. Are we able?
They'll be transferred locally inside OVS.
Okay, so if you have two pods, one which is VLAN 100 and one which is VLAN 101, so they are in two different VLANs, we are able to forward traffic from one pod to the other? Is this what you mean?
Yeah.
Okay, I understand this from your design, but the thing is that normally as a user, in terms of requirement, users tend to use VLANs also to isolate the traffic. So maybe a user, if they have two pods on two distinct VLANs, they don't want traffic from one VLAN to be forwarded to the other VLAN. Does that make sense?
And for this scenario, I prefer users to add additional network policy for this.
Okay. I mean, I understand. I understand where you're coming from. It's just that probably, and yes, if they add the network policies, they will achieve the same result. It's just probably that this is something that probably, at least we want to document, as it might not be obvious to users. They may think that, hey, I just configure a VLAN and I'm done.
Yeah, Zhang, I think the software means can be strange from user perspective, since they probably don't understand why the two ports in different VLAN can talk directly without going through the underlay router.
Yeah, okay, but okay, I think we can add additional.
So wouldn't naming VLAN differently in the CRD solve the problem? Like we implement this using VLAN, but in this, yeah, we just don't call it VLAN here.
No, but you say if I think it's possible people do want to put the ports in different VLAN, right? That's what we support with this feature. Of course, in some cloud case like NST, they can do some, I mean, VLAN type-based forwarding without really a VLAN being created. But if it's physical network with VLAN, then probably the intention just to put the port in different VLAN. But I'm not really sure it's a big issue or not. Probably we can also check with PMs to see if they have some.
The thing is that
answer.
the thing is that once we to the physical network, yes, we have a VLAN isolation. Inside the physical network, as Ran said, inside the OVS, to ensure isolation inside OVS, we'll need to couple that with the network policies. Now, yes, we can discuss from a requirement perspective whether we want to give, let's say, the same behavior that user will normally expect with the VLANs, or whether instead, we think that it is okay to have this sort of peculiar behavior, and then it's just documented, and so users know that they have to define a namespace with a VLAN tag, and additionally also configure the network policy for isolation.
Yep.
I think that that might be acceptable. It's just a matter of of knowing it, because also from what Ran said, it doesn't appear that there are ways of solving this issue in OpenVSwitch.
If we want, I think we can always forward the inter-VLAN traffic to uplink.
Yeah, that would be, that will be, yes, that will be the solution, right? We always forward it, no matter what, we always send it to the uplink. Yeah. Okay, so thanks a lot for the clarifications. So my other question is on slide 4 on the specification. And it's a very simple question. Do you think that we need to add validation or admission controllers for making sure that VLANs are unique, that that we don't have two namespaces using the same VLAN?
Yeah, currently, I think we don't need to verify it. Maybe users want to specify some IP range in pool 1 and specify another IP range in same VLAN in pool 2. So it's a use case we can support. So
Yep.
I think we should not restrict the VLAN occurrence only once.
I agree. That makes sense. Makes sense to me. Makes sense to me. Thanks.
For the question, Salvatore raised the how to forward traffic inter VLAN, but when the ports are on same node, I think maybe we could add a configuration, just like the Mac VLAN implementation, that there are two modes. In one mode, the traffic, the intra-node traffic can be forwarded directly inside the VM, and in other mode, all traffic will be will be forwarded to the physical network and sent back to the VM. I remember they are called bridge mode, and another one is called VEPA mode. Maybe that's one solution that can fit into two scenarios. And
yeah, I need to investigate if this will affect our existing use cases.
yeah, sure. And for the VLAN usage, I see that we have to pop the VLAN tag and attach and add a VLAN tag, depending on where the traffic come from and where it go.
Yeah.
So is this because we don't use normal action? So we have to do that manually.
Yes.
So if we go this way, do we really need to change the access, the attribute of the port, like access or trunk, or we could just use open flow to control the forwarding, because we don't leverage any benefit that the VLAN tag brings, right? With the VLAN, the traffic can be forwarded directly to other ports in same VLAN, and the up request can be broadcast. But I think in this implementation, we don't leverage any of that. For example, how will you handle the up request from one port to another port in same VLAN, and in another VLAN?
For up request, the action is normal, so it can be processed by OVS.
And
so we don't need to process up requests at this table.
Okay, if they are in different VLANs, it will query the gateway, so the request will go to the trunk.
Yeah, we will go to the uplink.
Do we do anything special for that request? Do we use normal or something like this?
Yeah, just existing up table is enough.
Okay, you mean normal?
Yeah.
Oh, okay, and then I think the VLAN tag is still useful for at least the up queries.
Yes, because OVS itself will process VLAN tag when it do the action normal. So for our design, we also I think we should follow the OVS design. We need to process the VLAN tag before we output packet to ports. So that's why we set the VLAN table before the output table, but it should be after of all other tables.
Okay.
Okay, good. Thanks for all the clarifications, Ran. And so we are targeting Antrea 1.6 for these new capabilities. Is that correct?
Yeah.
All right, perfect. Is there any other question for Ran?
I have another question. How many open flow rules are expected in this VLAN table? I mean, do you need one flow for each pair of ports, or
One flow for each VLAN pod. Okay, so you can see here, one flow for each VLAN pod.
But this is to uplink, right? If there is another port, how will you add another flow for another port?
Unless we add another trunk port, which allows all VLANs to pass, we don't need this. But as you said, if, for example, if we want to, users can configure VLAN IPs on the node, which means we need to set this BRInt port as the trunk and passes all VLANs. If we want to support this case, I think we need a conjunction in this VLAN table. The first one will match the import, and the second conjunction will match the register one.
Okay, I think we don't need that. Can I take your answer as we don't need a flow for each pair of port? We just need a flow for each port and each trunk port.
Yes.
Trunk port. Yeah. Okay. Thanks.
Yes. The flows should be n, not n square.
Thank you.
Great. Okay, so any more questions regarding the multi-VLAN design for flexible IPAM? Perfect. So thanks a lot, Ran, for your presentation. We are looking forward to the PRs and to enable this feature in Antrea. Now, moving up to open discussion, I believe that Yang would like to bring up an interesting problem that has also been discussed from what I recall in the SIG network meeting, and that also applies to Antrea network policies. Yang, are you there?
Yes, I am.
Cool.
Can I actually share my screen to demonstrate this?
Sure, go ahead.
Okay. Okay, I'll try to make this as quick as possible. So essentially, with the upstream cluster network policy discussions, the background is that we're trying to design the new cluster network policy API for the upstream Kubernetes. And in terms of design choices, we're encountering something that we may want to change in terms of the current network policy implement API specification. So as many of you know, in the current network policies, we can select workloads in a lot of different fashions. So for example, in the ingress rules, one of the ways to select workloads is using namespace selector, which selects all the workloads in namespaces matching one label. And the other way is pod selector, which means that regardless of namespace, as long as the pod matches certain labels, those pods will be selected. Now, the interesting part is that those two selectors can be used in conjunction, which means that the pods needs to satisfy both conditions, both the namespace selector condition and the pod selector conditions, for it to be actually selected by this conjunctive selection mechanism. So this was working in network policy implementation, but there's an interesting problem brought up because some people are actually trying to add new selectors to the network policy peers. For example, service account selector, right? So consider this, like I wanted to select service account pods with certain service accounts and match in namespace selectors, blah, blah, blah. And people are saying that, okay, we wanted to add this to the current network policy spec. Why can't we just throw this in, right? Because it's just another selector. And we can do some sort of like API validation to make sure that in a certain peer, the service account can only be standalone or to be used with namespace selector, but you cannot say something like service account selector and pod selector. That's just not valid. Why can't we do that? Now, the problem that brought up with this is that people realize that for old CNIs, adding this kind of things is not feel closed. It will feel open for some cases. So let's just consider Antrea as a CNI, right? When Antrea receives a network policy and it processes it, it will look at each ingress peer in this case. So it will say, as long as Antrea understands, there will only be three kind of cases. One is this, and the second is this, and the third case is this, right? So Antrea doesn't really know to look for something else. Now, if on the API side, the API server has been updated with a patched version of network policy, and the user created a policy saying something like namespace selector and service account selector, and the resources created through API server and persisted in ECD, whatever. And then Antrea, as an old CNI who has not been patched to support the service account selector, received this kind of resource. And what it will do is that it will look at this pair, and all it understands is that it has a namespace selector and no pod selector. So Antrea will process this the same way as this, because Antrea doesn't actually know to look for service account selector. That just doesn't exist for as far as the CNI know, because it's an upgraded CNI. And that creates a problem because in the actual implementation or realization of OVS flows, Antrea will just push down the addresses matching the namespace selector, but disregard this. And there won't be any errors thrown out because Antrea doesn't know that this is a problem. In fact, it doesn't even know at all that there's a field called service account selector existing in the new network policy spec because it doesn't know to look for it. So to summarize, the problem is that OCNIs may enforce the new API network policy API instances wrong without any warnings or errors thrown. And this is what we're trying to avoid in the upstream. That's why in the upstream discussions, when people are trying to bring service account selectors or something similar into current network policies, the short answer is no, because you cannot do that. It requires us to it will require the CNIs to sort of like do some sort of admission control for the network policies and specifically say that before I support service account selector in my reconcilers, you cannot create something like this, which is not ideal. So people are turning into something like network policy V2s to actually throw this in. And members in the SIG network space, specifically Tim Hawking, when we're having a conversation regarding the new CMP design, they're saying that this is a mistake we made when designing the original network policy for Kubernetes. Like this conjunction of selectors should never actually have existed in the first place. A better way to do this is to be extremely verbose and specific, so that instead of doing namespace selector, we needed to have a type, usually maybe called namespace and pod selector. And as a field of this specific struct, it will have a namespace selector and a pod selector as a subfield. So as you can see, there's a lot of redundant information, because here you will say, okay, the entire struct is a namespace and pod selector, and underneath you have namespace selector and pod selector. So this feels redundant. But what's good about it is that now you can mandate the network policy peer to be one of a couple of kinds. So the only valid kind will be namespace selector or pod selector, or this namespace and pod selector, or whatever the other combinations that we support in the future. Now, when CNI look at this, CNIs should look for a specific type. For example, the specific type being like an enum that it is already supporting. It's either namespace selector, pod selector, or namespace and pod selector. Now, when user created something like namespace and service account selector, CNIs will immediately know that this is a problem, because this is a new type that it doesn't really know about. In that case, it can throw out an error saying that, hey, I don't know how to implement this, or I don't know how to realize this in OVS, because you're using a new ingress peer type that I haven't been supporting yet. So this is the sort of like a result of the discussions we had. And I actually was talking to Grayson on his PR, that we probably wanted to incorporate this comment into some of the new designs we're making, specifically about service accounts. So right now in the service account API design, we're a lot of places we're using the old way, where when we're selecting service accounts, we're using a mixture of selectors. For example, the label selector, namespace selector, ANDed together or conjuncted together, and namespace name, which is another way of selecting this. Now, instead of doing something like this, we might consider doing something really explicit and verbose, so that under service account, we strongly type the kind of service account selection mechanism that we support. It's either a namespace name, or a namespace label and service account label selector, or let's say namespace label and service account name selector. So any kind of like valid combination that we wanted to support, we laid it out explicitly, so that people know that which kind of selection mechanism we're using. And by doing this, we are basically future-proofing ourselves. And any new selection mechanism we want to add in the future, we can be sure that everything that the new things are fail closed for old implementations, and we can add as many as we can add as many combinations that we wanted, and the number of combinations of this selector in the real case will not be the Cartesian product of all the selectors out there, because some combinations will just not make sense. For example, pod selector with ANDed with service account selector doesn't really make sense. So this will not be a combination that we support. And so that's why we won't have that combination as a type here. But the idea is that any combination that we support, we sort of like laid it out, so that when we define the open API validation for the service accounts, we can say the service account specification needs to be one of namespace name, or namespace label and service account label selector, or something else. So yeah, this is the the problem I'm trying to present. And this is for the new APIs that we are designing. But my feeling is that in a best case scenario, maybe we should also change the current ACMPs where we have the pause selector and namespace selector conjuncted in this fashion. Maybe we wanted to change them as well so that people create policies not like this, but using a unified struct with a different name. But I admittedly it will be a real headache because of the ACMP spec that we all have already rolled out. So that if we don't support this anymore, then it will be a huge backward compatibility issues. And if we support both this kind of writing and the other writing, it will also be really confusing to people. So, but the bottom line is that for the new API designs, we're trying to stick with this pattern instead of the old ones. Does this make sense to everybody? And does anyone has questions on this?
Yang, thanks for sharing the proposal. I
Yes.
agree that the type should be specific, should be specified explicitly. But my question is whether it could lead to too many structs, similar structs that have similar fields. For example, this namespace label and the service account label selector, and the namespace and the pod label selector. Could we use some unified structure to represent multiple types? For example, we could just have two basic types: namespace, the object selector, and just the object selector. And for the former one, we just have two fields. One is pod select, one is object selector, and another one is the type of the object. For example, it could be pod and the service account or service. Then it could be used as for other cases that you want cluster level objects and you want to specify the selector. And for the latter one, namespace, the object selector, it has three fields: namespace selector and the object selector and the type of the object. Could it also work for these cases? But I think it will just introduce new structs and it will not be too verbose.
On top of my head, I think that's doable, but I do feel like this will be a sort of like a very drastic different way than what we are doing in the other fields for current ACMPs. So it will be a little bit of a mind twisting for people to, when you write ACMPs, you select workloads in one sort of like fashion. And when you write about service counting ACMPs, then you need to write it in entirely different ways. But I don't know, it might not be a problem, but yes, I think that's a good proposal that we should definitely consider as well. Let's see. I guess I'll actually punt it to Grayson, who is also on the call, to do some very quick evaluation on if the one approach will be less defining less structs than the other, I guess.
Yeah, from my understanding, I guess maybe for service account, we can use the like you proposed in the on screen in the comments, and if we want to like use this kind of API design among all ACMP, like between namespace selector and the pause selector, we can try to do like add a field called type. It's a pod or it's a service account, and change the service account API design at the same time. If that kind of design will like use less struct.
Now the problem was, as I mentioned, the problem was changing the current way of defining ACMP or AMP is that we needed to consider upgrade, right? So essentially we for backward compatibilities, we needed to definitely support what we support now, and we wanted to also support new ways. For example, as Trent mentioned, we wanted to support a new type of workload selection API spec, and we needed to support both. So I don't know if that's going to be the best way moving forward.
Yeah, that's a tricky question.
Yeah, maybe, of course, we could discuss offline. I just brainstorm the idea. I didn't through it.
Yeah, sure. I think it's better to just put this idea like in YAML, I guess, first to sort of like evaluate how that will unfold, and then we'll see.
Right. Thanks a lot for bringing this up, and I believe that probably as the outcome of this conversation is that as anything pertaining API specs, it needs more conversation. So since we are almost top of the hour, perhaps this is something that we can keep discussing in the next community meeting, and it might help providing some more YAML examples. And also, I believe the other important aspect to keep in check is potential backward compatibility implications and figure out how to handle those. But this is something that I believe we can address in the next community meeting in 2 weeks' time. And is there any other question or comment regarding what has just been discussed regarding selectors? All right, it appears then that is all on this topic. As we have a few more meetings to spare, if you have anything else to bring up, please go ahead. Otherwise, I'll wait as usual for a few seconds, and then we'll close today's meeting.
Maybe I could give a quick update about the release progress of 1.5.
Sure.
Currently, major code change have been merged, except the PR for merging the multi-cluster branch to main branch. So I would appreciate that the reviewers of that branch could review the merge PR so that we could proceed the release progress. Yeah. And some other minor PRs are still pending on reviewing. For example, the doc and end-to-end test patches for new features. Yeah, that's what we need currently. And I will write a release note maybe today, and hope you could review that PR tomorrow. Then we can ensure that the release can go out this week. Yeah. Thank you.
Chance, when you want to cut the branch, is that the release branch?
Yeah, I'm still waiting for the patches, the PRs to be merged. The PRs I mentioned above. The major one is the PR that merges multi-cluster branch to main branch, and some few other PRs for end-to-end and docs.
Yeah,
and
I mean, do you have a expected deadline if we want to release on time?
Yeah, maybe 14 or 24 hours from now. Maybe
Okay.
that would.
Yeah, today I just committed with with CK. We want to deliver by end of this week. So I think yeah, we need some review as soon as possible.
Okay. Another one at our CI, I still see some tests frequently fail. Is that due to the test case or due to the CI? Do you see the same thing, or just me see the feeling?
I didn't see many flakes. Is it about one specific job or many of them?
For example, I was looking at the PR by around for secondary network support. I saw the multiple tests failed. Sometimes the integration test failed. Sometimes the end-to-end test failed. But probably I should look into a test to see what's the reason for the failing.
Sometimes the integration test indeed failed. I think it is still a little flake today.
Okay.
And end-to-end sometimes failed on the aggregator test.
I see.
That's the current flakes I know.
Okay, got it.
All right. Cool. So I think that might be all for today's meeting. And I would like to thank everyone for joining this call. Most importantly, thanks to Ron for presenting the new design for multi-VLAN, and many thanks for Yang for bringing up this problem with syntax, network policy API syntax, and semantics. And I guess that's all for today. So thanks again for joining, and I will talk to you. We will talk again in 2 weeks' time. So I wish everyone a good morning, a good afternoon, a good evening, and a goodbye.